350, that's right. Alright, come to number C. Yeah. Calculate the time it will take for the size of population to decrease to 120. Yeah. So you can use here and solver. 8.64 days. So since they haven't mentioned anywhere that you need to write it to the nearest integer, so I'll take it as three significant figure, that is 8.64 days. Prime representing the days, so we have it in days. Yeah, we don't have it, but theoretically we need to mention that because not nobody mentioned here like you need to write it to the nearest integer. There is nearest integer. If they should mention that here, you need to write your answer to the nearest integer, then we will switch to 9, but it's not mentioned over there. So I'll take it 8.64. So the population will stabilize when it reach a size n. What is that n? Let's increase the time so big. Yeah, so t tends to infinite, and so it's 8000 divided by 2 power infinite plus 100. Yeah, since 8000 divided by 2 infinite is tends to 0, because I'm dividing 8000 with very big number, very big number. 2 raised to the power infinite is very big number, and when you're dividing any number with very big number, the result is 0. 0 plus 100, so it stabilizes when it reach 100. So n is 100 here. Yeah, n is 100. Yeah, because that thing becomes 0. 8000 over 2 raised to the power infinite is tends to 0. So the only thing left is here, that 100. 2 to the power 0. I'm not taking t as 0. I'm taking t as infinite. So 2 raised to the power infinite, and it's negative t. So it means it will come in denominator. Do you know the rule of exponent? A raised to the power minus m is 1 over m, right? So it's 2 raised to the power infinite, and 2 raised to the power infinite is a big number, very very big number, very very big number. So dividing anything with very very big number, the result will be 0. So adding 100 with 0, the result is 100. You can take any big number and divide that 8000. So take any big number and divide it by 8000 with a big number. hmm Is it done? Okay. So just write in a calculator 8000 divided by 2 power 2 power, let's say 9999999. Alright. Yes, so we can do this one. I think this one is also your doubt. Yes. So what you can do, you can draw the function that is mentioned over here. You go to the graph and delete if it is any graph is already put over there. So go to the graph, write this graph over there, 0.2 e raised to the power x plus 2 minus 4. Make sure your graph is uh, having the dimension or domain from -3 to 2. X-intercept. X-intercept. X-intercept is 0.9957. So I'll take 996. So that is what the x-intercept is, 0.996. It's almost nearer to 1 but not exactly 1. It's 0.996. That's my calculator. Or even if you solve it by using AND solver, you can do that. Like what is the how to solve the x-intercept? Just putting y0, fx0, and that's equal to 0.2 e raised to the power x plus 2 minus 4. Do the AND solver here. And y is, yeah, so y is negative 2.52. So if you want to draw the graph, how it looks like something coming like to 0.52. So I will cross it like to 0.52 and like this, something like this. Now it is transformed. The graph f is reflected. This graph f is reflected in the x-axis and then translated 1 unit in the positive x direction and 2 units and 2 units in the direction of positive y-axis. So lots of transformation is happening over here. Reflection is happening. Reflection on x-axis. Reflection on x-axis. It means it will going to reflect like your new function is minus of the old function, minus of fx, and then it is actually translated 1 unit to the right. So it means it will be minus of fx minus 1 bracket. It is also translated 2 units in positive y direction, so it will be plus 2. So it is actually gx is equal to minus bracket f, which is 0.2 x e raised to the power x plus 2 minus 1 bracket close plus 2. There is minus 4 also, so I'll write it minus 4 in the bracket. So it is minus 0.2 e raised to the power 2 minus 1, so x plus 1, and minus 4 is plus 4 plus 2. So minus 0.2 e raised to the power x plus 1 plus 6. This is what my gx after the transformation. hmm Okay, not an issue. We're going to take the transformations one by one. We also have class on tomorrow, so we're going to take the transformation questions tomorrow. Alright, let's come to simple log question. Okay. here it will be ln 2 power 4 minus ln it, right? 2 power 4 is 2 times 2 4, 4 times 2 8, 8 times 2 16. ln 16 ln minus ln 8, so ln 16 over 8, that is ln 2, right? Mm-hmm. Mm-hmm. ln 2, and when you put minus over 2x, so what it is? So 1 over 2x. Now you can mitigate this ln, I mean just cut the ln or just erase the ln, because both we have, yes, we have the same base, that's why, because it is ln is having base e, a log is having base e is known as ln, so we can just, yeah, 2 is equal to 1 upon 2x, so we can do the cross multiplication, so it's 2 times 2x is equal to 1, 4x is equal to 1, so what is x? X is 1 over 4, x is 1 over 4. I cross multiply and it's become 4x, 4x is equal to 1, 4x is equal to 1, so 4x is equal to 1, dividing both sides with 4, so what is the x? X is 1 over 4, x is 1 over 4. All right. Another question from Exponent Modeling. Did you get the question while reading it? Use the model to estimate the population of bird on 14 March 2023. Right, so what is the population on March 14, 2023? So it was actually uh, started from 14 March 1973. On that time, the function was modeled as uh, PT as population as 10 e raised to the power kt, and on March 1993, the known population of bird was 50. So from 73 to 93, how many years? 20 years. For 20 years, the population reaches 50. Yeah, so that can give you the value of k, right? Mm-hmm. Okay. Okay, so what is the initial population? We have 10, so let's figure it out. P20 is equal to 50, so we have 50 is equal to 10 e raised to the power k times t as 20. I can do the unsolver over here, and solver over here, right? Okay, so when you do this, it will be e raised to the power 20k is equal to 50 divided by 10, which is 5. So Hmm. E raised to the power x. K is 0.08047, so I'll take 5. Three significant figure. Mm-hmm. Mm-hmm. It's not simple interest, it's a compound interest kind of thing. It's not simple. Mm-hmm. So we have the population after 50 years we need to find uh, on March 2023, that is P50. Yeah, that's right. Yeah. So it's 502 is equal to 10 1 plus r over 100 raised to the power 50. That is giving the r value, that is 8.15 approximately. That's right. Okay. Let's take a question from log equation, where you have to deal with log equations and you need to solve it without the help of calculator. Just use the log property to crack this log. Mm-hmm. X is 60. I hope you haven't used any kind of calculator. Alright, let's see. So we have log base 5 x minus log base 5 4. That's equal to 2 plus log base 5 3. Can't I write this 2 in terms of log base 5? And we can write that like log base 5 x minus log base 5 4. We can write like log base 5 5 square plus log base 5 3, isn't it? So you can see here we all have terms in base 5. So what is the property here we can use? Log base 5 x over 4, right? X over 4, and that's equal to log base 5 5 square 25 over 3. 20, oh okay, it's not 25 over 3 because that is plus, so it will be 25 times 3. Right, so subtraction of 2 log is the quotient and the addition of 2 logs is multiplication. Right, so now we have log base 5 both sides. Now I can leave log base 5 and I have just the numbers, the arguments, that is x over 4 equal to 25 times 3, which is 75. What is the x? It's 75 times 4, that is 300. That is 300. Yeah, the answer is 300. Yeah. Two as what? Log? Okay, so it is 1 plus 1, that's also 2. Okay, okay. And then what are you going to do? Plus log base 5 3. Right. Then 5 times 5, because ultimately you have to multiply them by the rule. The rule is log base 5 into multiply 5 5 3. So it will be log base 25 times 3 75. Okay, not an issue. You can try now a few questions from this log, right? And the log questions I have already shared you that sheet. You can go ahead. We'll take more questions like that. Okay. All right. I think we are done for today. See you tomorrow, same time. Okay. Any doubt in this question? All right. Okay then. Bye. Take care.